Hello everyone, I'm Dr. Emilia Bertolo and I'm a principal lecturer in chemistry at Canterbury Christ Church University in the section of Natural and Applied Sciences. This is the first of a series of videos dedicated to the concept of chemical bonding. We will be looking at the basic principles that governs how atoms form bonds and what type of bond atoms will form, covalent, ionic or metallic. We will be delving a little bit into the formation of ions and how atoms make ions. We will also be looking at how the chemical and physical properties of a compound are going to be governed by the type of bond that compound is made of. So covalent and ionic and metallic compounds will have different properties, and we will be looking into that. We'll also be looking very briefly how to name compounds and how the name of a compound can give us an indication of what type of compound we are looking at, either covalent or ionic, etc. And finally, we will be looking at a very specific type of covalent compound. They are called coordination bonds, coordination compounds. We'll be looking at how those coordination bonds are made of and why would we care about the fact that the coordination compounds exist. And I will be giving you several examples that are related to the life and environmental sciences. As with previous videos, as with the rest of these videos, these are not videos aimed at chemists. So by no means you will be experts in how atoms make bonds, and that's not the point. It will not be useful for you. My aim is to give you a good understanding of how compounds are formed, an underlying understanding of how atoms form bonds and how those different types of bonds will determine the behavior of those chemicals in organisms, in the environment, in the world around us. A brief reminder of some key concepts when we're looking at the structure of atoms. We discussed in previous videos that electrons do not circulate freely around the nucleus. They're actually restrained to specific energy levels. That electrons, and we call those energy levels, are specifically in certain areas of space where you are more likely to find particular type of electrons, and we call those particular regions of space where you have the sort of equal and high probability of finding those electrons orbitals, and we discuss s orbitals and p and f and d orbitals. Electrons will fill orbitals of the lowest energy level first, so closest to the nucleus, and the more electrons you have, the larger the atom is, the more electrons it has, the more those electrons will position themselves further and further away from the nucleus. And the electron configuration of elements is related to their location in the periodic table, or the other way around. The electronic configuration of elements means that they will be located in the periodic table in particular places, and we talk about periods, which are the rows, and we talk about groups, which are the columns, and all those atoms in that particular group and in that particular period have an electronic configuration along the same lines. So what is a chemical bond? Well, we can define a chemical bond as the attractive force that holds atoms together into more complex units. And we call those complex units compounds. And when there's a specific type of bond, covalent bond, we call them molecules. But compound is a general name. So basically, you have the atoms, but atoms are not independently, they are making compounds. And the forces that keep those atoms together in that compound is what we call a bond, a chemical bond. And there are three main types of chemical bonds between atoms. There are what we call ionic bonds, covalent bonds, and finally metallic bonds. When you're looking at chemical bonds, you think of something called valence electrons. And those valence electrons, in a sort of simplified way, can be thought of as the outermost electrons, the ones that are further away from the nucleus. And because they're the furthest away from the nucleus, they are the less attractive to the nucleus and the more interested in reacting with other atoms. So when atoms interact with each other, they never interact with the nuclei, they interact with their electrons, and not all their electrons, but the outermost electrons, the ones further away from the nucleus. When we have what we call representative elements, which are the ones at the right of the periodic table and the two groups that are at the left of the periodic table, we call it, those electrons are in s orbitals and p orbitals. And when you have the transition metals, which are the ones that are in the middle of the periodic table, and the lanthanides and actinides, that are the sort of two periods that you have below a typical periodic table, those electrons are going to, those more outermost electrons are in the s orbital, but also in d orbitals. And we care about that in general terms because all those electrons, either s, sp, or S and D are the electrons that our atoms will use to make bonds, and that's why you will have a richer chemistry in the case of some elements and a slightly less exciting chemistry in the case of other elements, because they have a different number of valence shell electrons to play with. In the next few slides, in the next few videos, I will be exploring what's an ionic bond, what's a covalent bond, and what's a metallic bond. But the underlying reason is sometimes atoms will make what we call ionic bonds and an exchange of electrons. So one atom will become positively charged and the other one negatively charged, and they will be held together by electrostatic interaction. Positive charges attract negative charges. Sometimes a compound will be held together because atoms share electrons. So there's no a positive charge or a negative charge, there is a sharing of the electrons between two or more atoms. And then you have the metallic bond, that is the one that metals make with other atoms of the same metal or the other metals. So when is it one or the other? When is it ionic? When is covalent? When is metallic? Well, metallic bond is what happens, what holds atoms of metals together. But what about ionic and covalent? When do you have a sharing of electrons and when do you have one atom giving electrons to another atom? Well, to predict that, or to understand why sometimes there is a sharing of electrons, sometimes there is an exchange of electrons, we have to look at two periodic table properties: ionization energy and electronic affinity. And we covered that in previous videos. Ionization energy tells us how easy it is for an atom to lose an electron and become positively charged. So it's energy that you have to spend to take an electron away from an atom. So the lower that ionization energy, the easier it is for that atom to become positively charged. And on the other hand, you have electronic affinity. Electronic affinity is the energy liberated when an element gains an electron and becomes negatively charged. So it's an energy liberated. The higher that electronic affinity, the easier it is for that atom to become negatively charged. So when you have an atom that has a low ionization energy or ionization potential, you will find in some books, that means it finds it easier to become positively charged. Interact with another atom that releases a lot of energy when one electron, has a high electronic affinity, that finds it easy to become negatively charged, then you have a perfect combination to form an ionic bond. And a perfect example for that is the atom of sodium and the atom of chlorine. Sodium finds it easy to lose an electron and become positively charged, and chlorine releases a lot of energy when it gains one electron and becomes negatively charged. So you have the perfect combination. Those atoms, when interacting together, will find it most energetically efficient to do that exchange of electrons, because the energy that the sodium is required for taking an electron away from the sodium is well compensated by the amount of energy liberated by chlorine by chlorine when it attracts that electron in its outer shell, when it gains an electron. And you tend to have that interaction between metals and non-metals in binary compounds that are made only of two different atoms. However, in many cases, that doesn't work that well. One of the elements doesn't find it that easy to become positively charged, and so there is quite a lot of energy required for that atom to become positively charged, and the atom that has to become negatively charged actually doesn't liberate that much energy to start with to become negatively charged. So when you have an atom that has a medium to high ionization potential, and another atom that has an electronic affinity which is too low, and it doesn't matter which way you try to think of which one is going to become positive and which are negative, the energies don't quite stack up, then they don't become an ionic compound. It's much more energetically efficient for them to share electrons. So nobody loses electrons, nobody gains electrons. They are shared between two atoms. And then you have what we call a covalent bond. So ionic bond is when electrons are transferred, 1, 2, or 3 typically, between one atom and another. And a covalent bond is when atoms are shared, when electrons are shared between two atoms. And we will see that sometimes it can be a bit muddled because there are many atoms that are somewhere in between, and we talk about a covalent with an ionic character or ionic with a covalent character, etc. But in a sort of, if you want to try to divide the world in three different categories, ionic, covalent, and metallic are the three normal types of bonds that we tend to consider. So as I said before, in many cases, the things are not that neatly distributed, but in general, for what we call simple compounds, which we tend to mean binary compounds that are made with only two types of atoms, you tend to have the following combinations. If you have an atom which is a metal, and in this periodic table, for example, the metals would be roughly all around here, and also including the lanthanides and actinides. So when you have a metal interact with a non-metal, and for the non-metals are here in green, you have the hydrogen and you have the sort of little corner over there, then there is an electron transfer. The metal will lose the electron, the non-metal will gain the electron, you have an ionic bond. When you have two non-metals react, let's say that you have hydrogen and you have chlorine, and you make the compound HCl, hydrogen chloride or hydrochloric acid, then the energetic considerations do not work so well. There is one that loses the electron, the other one that gains it. The hydrogen and the chlorine will share one electron each and will make the bond by electron sharing, and we call that a covalent bond. And finally, you have the bonds that metals make, either with let's say, for example, iron, either with itself, when you have a lump of iron metal, or a mixture, let's say, of iron and aluminium, when you have an alloy, or silver and gold. Doesn't have to be the same element. It can be a mixture of metals. That's how you make alloys. Then what we have is what we call electron pooling. All the electrons from all the atoms are shared across all of them, and you end up with is typically called a sea of electrons. And I have a in the future videos I have a slide about this sea of electrons, how this might look like. So again, this mostly works really well for binary compounds or for metals with metals in a metallic bond. If you have a metal and a non-metal, then you have an ionic bond. If you have two non-metals interacting, then you have a covalent bond and there is a sharing of electrons. So nobody loses, nobody gains electrons, they just share them. And when you have metallic atoms reacting with others, you have a metallic bond.